amid the shimmering night of the cosmos, there exists a small, restless world glowing like a solitary torch beside the sun. Mercury, the most extreme planet in the solar system. A place where light sharpens like a blade and darkness grows cold enough to crack memories. Tonight, we drift gently toward that world, touching secrets only ancient time dared to keep. If you've ever wondered what makes Mercury so profoundly different, leave a comment and share the intuition stirring in your mind. Perhaps your thought is the missing piece of this story. And now, we ask ourselves, why is Mercury such an incredibly difficult place to reach? Beneath the burning breath of the sun, there drifts a small world that many forget. A world that glows like a coal caught between light and emptiness. Mercury is often called the Mercury Extreme Planet, not because it wants such a title, but because nature sculpted it into a frontier where the rules of exploration are rewritten with every sunrise. NASA scientist Sean Solomon once said that Mercury is the planet that teaches humility to every spacecraft we build. And the older I grow, the more I understand why those words linger in the mind, like heat shimmering above stone. To approach Mercury is to step closer to the sun's gravity well. And that descent is not gentle. A spacecraft falling inward accelerates relentlessly, dropping like a meteor through a gravitational river without end. Every kilometer gained toward the sun increases velocity in a way no engine can comfortably resist. And deceleration becomes an art form of slingshots and stolen momentum. If we flew straight toward Mercury, the craft would not meet the planet. It would overshoot and vanish into the sun's pull like a snowflake drifting into fire. That is why every mission must loop around Venus, around Earth, around Mercury itself, again and again, reshaping speed the way a river polishes stone. This journey is long not because Mercury is far, but because it asks for patience. The closer we come, the more the sun stretches its invisible fingers, heating metal panels, pressuring electronics, and filling the surrounding space with storms of charged particles. James O'Donoghue once remarked that, near the sun, space is not empty, it is violent. And that truth sweeps through every bolt of every Mercury-bound craft. The temperature alone is a kind of poetry. Fierce, contradictory. On one side of the planet, heat rises above 430 degrees Celsius. Hot enough to soften metal. Hot enough to erase the boundary between rock and ember. Yet just a breath away. On the night side, the cold sinks to nearly -180. A cold so sharp it seems capable of carving the silence itself. These extremes are not gentle landscapes for machines. They are trials, tempered over billions of years. Radiation washes across Mercury like tides on a shore made of stone. And every spacecraft must carry shields thicker than reason just to survive. Solar wind storms flood the magnetosphere in bursts, snapping magnetic lines, compressing fields until they breathe like wounded lungs. Even its surface is not safe. Meteorites rain upon it more fiercely than anywhere else in the inner solar system. There is no air to cushion them. No sky to burn them away. Every stone falls whole, and every impact leaves scars as wide as cities. Messenger spacecraft scientist Louise Proctor once said, Mercury is a planet that has lived a hard life and remembers every injury. And indeed, the planetary crust is a script of trauma. Cracks, folded cliffs, frozen lava plains. Each feature whispers about a time when the planet burned with volcanic fury, when its core surged and cooled, when impact basins formed like rings on an ancient tree. But for all its drama, Mercury remains quiet, patient, almost waiting. And so the question arises: if Mercury is closer to Earth than Jupiter, why is it visited so rarely? The answer flows not from distance, but from difficulty. Jupiter holds a soft generosity compared to Mercury. Its gravity wells are far but predictable. Its radiation belts known. Its approach gentle compared to the Sun's scorching domain. Getting to Jupiter is a matter of reaching outward. Getting to Mercury is a matter of falling inward without being destroyed. The Sun's gravity is a king that tolerates no recklessness, and every spacecraft must bargain with it through dance, not confrontation. We trade energy through flybys, surrender speed in arcs around brighter worlds, and spiral inward in long meditative curves. Each mission takes years, not because the planet hides, but because survival demands the slow path. I have often thought about what it means for a world to be so close to a star, and I suspect that Mercury is less a planet and more a lesson. A reminder that proximity to brilliance comes with a cost, that heat is both illumination and peril, that some truths are reachable only through patience. And there is a kind of beauty in that, a meditative rhythm that speaks to anyone who has ever stood too close to something powerful, admired it, feared it, and yet still felt drawn onward. Mercury shows us that exploration is not always about arriving first, but about arriving alive. It teaches that the universe is not simply a place to conquer, but a vast, quiet teacher whose lessons deepen with time. The brilliant physicist Eugene Parker once reflected that the sun shapes every world around it, but Mercury listens closest. Perhaps that is why it fascinates us, because it stands in the place where silence and violence meet, where survival itself is a triumph. When I think of Mercury now, I see not a hostile rock, but a spiritual frontier, a world that invites us to slow down, breathe, and understand the nature of extremes. And if there is a lesson I carry from its story, it is this: that every journey worth taking requires both courage and gentleness, both ambition and patience, and above all, the willingness to learn from the silence between the stars. So, when we ask why Mercury is so difficult to reach, perhaps the deeper truth is that it mirrors the challenges within us, the parts that run hot with desire, cold with fear, and yet move forward anyway. The Mercury extreme planet is not merely a destination. It is a meditation, a quiet reminder that discovery is earned slowly, like light rising from behind a distant horizon. And maybe, just maybe, that is what makes Mercury worth the journey. Beneath the quiet breathing of the cosmos, where light drifts like ancient incense toward forgotten horizons, there is a question that has puzzled countless minds who study the pathways of interplanetary travel. Why must the Bepi Colombo spacecraft sail farther than the distance to Pluto just to reach the small, scorched world of Mercury? To many, this seems like a contradiction, a cosmic riddle hidden in the geometry of orbits and the invisible hands of gravity. But once we allow ourselves to move slowly through the story, to feel the dance of mass and motion like a tide beneath our thoughts, everything becomes unexpectedly lyrical. Scientists often say that space is not a place of straight lines, but a canvas shaped by forces we can sense only through their effects. A vast ocean where currents of gravity carve the routes we take. The astrophysicist Giovanni Bignami once remarked, "To travel through the solar system is to negotiate with the sun itself. For every destination belongs to its gravity. And nowhere is this truer than on the road to Mercury." At first glance, Mercury seems deceptively close. A small grey bead circling just inside the dawn of our star. But the closer a spacecraft approaches the sun, the more violently the sun pulls, adding speed as though hurling the traveler inward with a fierce and ancient authority. This means that any craft heading directly toward Mercury is accelerating every moment it falls deeper into the sun's gravitational well, gaining too much momentum to be caught by the tiny world below. This is why Bepi Colombo must embark on a pilgrimage of detours, looping around Earth, gliding past Venus, and grazing Mercury again and again. These flybys are not delays. They are gentle conversations with gravity, requests for the cosmos to remove speed instead of adding it. As NASA engineer Chen Wang-Yen once said, "Sometimes the longest path is the only one that slows you down enough to arrive." To approach Mercury is to fall toward the sun, yet to orbit Mercury requires resisting that very fall. Bepi Colombo must reduce its velocity so dramatically that it almost becomes still with respect to the planet. A fragile balance like a leaf hovering above a flame without being consumed. In deep space, slowing down is far more difficult than speeding up. There is no air to brake against, no friction to help. Only the silent expenditure of precious fuel or the clever borrowing of gravitational energy during planetary encounters. The sun is the reason for all of this. Its gravitational pull is the loudest voice in the solar system. And any spacecraft nearing its domain becomes a stone dropped into a bottomless well. Every second, the sun increases the velocity of Bepi Colombo, urging it forward with a force older than the planets themselves. If the spacecraft were to go straight to Mercury, it would rush past too fast to be captured, like a comet briefly brushing a world before vanishing into light. The physicist Kip Thorne once said, "Gravity is the sculptor of trajectories, and we are merely its witnesses." And so, Bepi Colombo obeys the sculpting, following a path that stretches billions of kilometers. Not because Mercury is far, but because slowing down enough to kiss its orbit requires the patience of a drifting star. This leads to an elegant truth, that the shortest distance is not always the fastest arrival, and sometimes not even the possible one. The spacecraft's elongated journey is a lesson written in celestial mechanics, showing us that in a universe ruled by gravity, direction matters far less than energy. Bepi Colombo's long voyage is also a testament to human ingenuity, a reminder of how we navigate a system built on laws we cannot bargain with, only understand. The spacecraft moves with the quiet patience of monks tracing sacred circles. each flyby shaving away speed, each loop bringing it closer to the delicate tempo required to fall into Mercury's orbit. And Mercury, that shimmering world battered by sunlight and silence, waits for its visitor with the stillness of a desert carved by ancient winds. For centuries, it has revealed only glimpses of itself, always half illuminated, always elusive. Messenger showed us much, but Bepi Colombo will show more. Mapping the magnetic field, the exosphere, the scars of volcanoes frozen in mid-eruption. As we drift deeper into this reflection, another understanding surfaces. The route we take through the solar system mirrors our own paths in life. We often want the straight line, the fastest way, the direct plunge toward our goals. But the universe whispers otherwise, teaching us that sometimes we must circle around familiar places, revisit old gravitational wells, and allow time to slow us down before we can arrive where we truly belong. My own view is that Bepi Colombo's Odyssey is not merely a feat of engineering, but a parable about patience, humility, and the subtle art of moving through powerful forces without resisting them blindly. Just as a spacecraft must bow to the sun's pull, we too must sometimes yield to larger currents in order to find our orbit. As the astronomer Carl Sagan said, we are a way for the cosmos to know itself. And through missions like Bepi Colombo, we are watching the universe reveal a piece of its story, one slow and luminous chapter at a time. If this journey stirs something inside you, if the quiet logic of gravity feels almost poetic, consider leaving a like or subscribing, not as a gesture of routine, but as a small act of joining this shared voyage. Your presence here shapes the constellation of minds traveling with us, and every comment you leave becomes part of the map we draw together among the stars. And as the spacecraft continues its long descent through sunlight, we too can follow gently, listening to the slow heartbeat of celestial mechanics, and remembering that even the hardest journeys are simply motions of energy seeking balance. This, perhaps, is the quiet blessing of Mercury exploration. A reminder that in a universe built on motion, every destination is also a lesson. Every orbit, a meditation, and every long path, a necessary curve toward understanding. In the quiet vastness between planets, where sunlight thins into a pale whisper, the journey of Bepi Colombo unfolds like a meditation on motion and gravity. It is a voyage not defined by straight lines, but by spirals, by slow arcs, by the soft choreography of celestial bodies guiding a fragile machine toward the most extreme planet in the solar system. You may wonder why a spacecraft must brush past Earth, then Venus, then Mercury itself, again and again. Why it must loop around the Sun 18 times. Why its path seems less like a route and more like a slow cosmic waltz. As Carl Sagan once wrote, "Space is not for the impatient." And in the quiet difficulties of reaching Mercury, those words become almost literal. To fall inward toward the Sun is to surrender to its gravity. A gravity so overwhelming that even a slight misjudgment of speed would send Bepi Colombo plunging into the stellar furnace. So the spacecraft must slow down, not in the way a car slows on a road, but in the way a feather hesitates in a breeze. It cannot fire rockets endlessly, for rocket fuel is heavy, finite, and every extra kilogram steals space from the scientific instruments that carry our questions. Flybys become the gentlest solution, a method older than the space age itself, a way to borrow momentum from worlds and hand it back to the sun. During a flyby, Bepi Colombo glides close to a planet, slipping through its gravitational field like a swimmer brushing through a current. In that fleeting moment, the planet's pull alters the spacecraft's velocity, shaving just enough speed to keep it from falling out of rhythm. James O'Donoghue of JAXA once remarked, "Flybys are not shortcuts in distance. They are shortcuts in energy." And in this story of falling toward the sun, energy is everything. Earth offered the first embrace, a gravitational handshake to send the craft sunward. Venus provided the next two, its thick atmosphere glowing beneath the spacecraft as if illuminated from within. And Mercury, small yet fierce, demanded 6. Each pass a reminder that reaching the innermost world is like descending a staircase where every step must be carefully measured. 9 flybys, not by choice, but by necessity. For Mercury's orbit is tight, fast, and dangerously aligned with the Sun's furious pull. Without these carefully spaced encounters, Bepi Colombo would either overshoot the planet forever or fall helplessly inward. As ESA's mission scientist Johannes Benkoff said, "To arrive at Mercury is to arrive slowly, for haste belongs to the Sun." But why circle the Sun 18 times? Why endure the long arcs of heat, radiation, and silence? Because orbit insertion requires a level of precision that borders on poetry, a delicate balance where velocity, distance, and direction must all align in a single breath of time. Those 18 solar loops carve away speed layer by layer, like waves smoothing a stone. Each orbit is a quiet inhale, a moment of adjustment, a chance for the spacecraft to settle into the rhythm Mercury demands. Neil deGrasse Tyson once reflected, "In space, motion itself is the story." And here, that story is shaped by gravity's patient hand. From a personal perspective, I find something profoundly moving in this choreography between machines and planets. It reminds us that exploration is rarely a matter of force, but of harmony. The spacecraft does not conquer Mercury. It learns to dance with it. And in that dance, we glimpse a truth about our own species. That curiosity endures even when the path winds long and slow. The lesson here is quiet but powerful. That progress often requires patience. That precision can be more powerful than speed. And that even in the cold emptiness between planets, there is beauty in the way we choose to move. As Bepi Colombo continues toward its destination on the wings of gravity and faith, we are reminded that space is not conquered. It is courted. And perhaps, in watching its long pilgrimage around the sun, we learn a little about how to move through our own universe. Slowly, deliberately, with wonder. The Bepi Colombo mission is not merely a scientific endeavor. It is a meditation on motion, an inquiry into the nature of falling, and a testament to our relentless desire to understand the places where heat and shadow meet. And as we drift with it in imagination, suspended in the warm darkness between worlds, we cannot help but ask ourselves a final question. If it takes 9 flybys and 18 orbits to reach Mercury, what deeper mysteries must await us when we finally arrive? In the quiet darkness between worlds, where sunlight is only a distant memory and space drifts like a slow breath, the story of Mercury unfolds in a way few people ever hear. It is a story not of brightness, but of shadows, not of perfect knowledge, but of boundaries that even our best spacecraft could not cross. When NASA's Messenger mission finally reached Mercury, it became our first patient observer in that blistering realm. Yet even with all its brilliance, the spacecraft found itself tracing an orbit that revealed only half a world. Why did Messenger explore so much of the northern hemisphere and so little of the south? The answer begins with the ancient tug of the sun, a pull so powerful that every spacecraft must bargain with it. Messenger did not enter Mercury's orbit by force, because no rocket could have carried enough fuel to fight the sun directly. Instead, it spiraled inward, using gravity itself as its guide. This long pilgrimage produced a delicate dance, a path tilted naturally toward the north as the spacecraft settled into a highly elliptical orbit. Space has a way of choosing what it will show us, said planetary scientist Sean Solomon, principal investigator of Messenger, and Mercury revealed itself in layers. The sun warmed Messenger on every pass, pushing its engineering limits, making it impossible for the spacecraft to maintain low orbits around both hemispheres equally. At periapsis, the closest point of its orbit, Messenger skimmed over the northern hemisphere at altitudes low enough to draw detailed maps. But as it soared away on each loop, the spacecraft retreated far above the southern hemisphere, offering only distant glimpses. This asymmetry grew into one of the great Mercury mysteries, a reminder that even with our finest tools, space exploration remains a negotiation between curiosity and cosmic reality. Some scientists even joked that Mercury was shy, lifting one shoulder toward us and hiding the other behind the sun. But the truth is simpler and more humbling. Messenger's orbit was the only orbit possible, the only one that allowed the spacecraft to survive the heat and complete its Crote's mission. In the words of astronomer Carl Sagan, every planetary mission is a triumph of patience over distance and of hope over harshness. Mercury was harsh indeed, and Messenger did what no one thought possible. Yet even its triumphs left a longing behind, a missing half of the story. The southern hemisphere remained like a dream partly remembered, with features barely traced, craters without names, plains without history. We knew Mercury's north like an old photograph, but the south remained blurred. That incompleteness became one of the most compelling arguments for a new mission. Enter Bepi Colombo, a joint gift from Europe and Japan. A spacecraft built not just to continue Messenger's work, but to heal its limitations. Where Messenger traveled alone, Bepi Colombo arrives as a pair of orbiters. Two perspectives, seeing one world. One dedicated to the surface and interior, the other to the mysteries of magnetic fields and solar winds. Together, they will trace orbits more circular and more even, allowing them to sweep low over both hemispheres. the South at last will step into the light. This is why Bepi Colombo matters, not simply for new data, but for wholeness. A planet half known is a story half told. In the words of astrophysicist Neil deGrasse Tyson, the universe is under no obligation to make sense to us, yet Bepi Colombo is our way of gently insisting. We want to understand. We want to listen. We want to see Mercury not in fragments, but in fullness. When I think of Messenger's northern maps, bright with detail, alive with volcanic plains and strange tectonic scars, I imagine Mercury offering us its first whisper. But when I imagine Bepi Colombo sailing closer to the southern hemisphere, tracing valleys unseen and craters untouched by human knowledge, it feels like the planet is finally turning its other cheek toward us. There is a kind of poetry in that, a slow unfolding, like the pages of an ancient book whose ink glows softly under starlight. Messenger taught us much, more than we ever hoped. Yet it also taught us humility. It showed us that exploration is not a straight line, but a spiral, a looping journey shaped by forces far greater than human will. It left behind questions we could not answer, but that is what all great missions do. Among the lessons Messenger offered, one stands out to me most of all. Knowledge is not simply the accumulation of facts. It is the unfolding of perspective, the widening of vision, the acceptance that every insight also reveals a boundary waiting to be crossed. We do not explore to conquer planets. We explore to complete ourselves. Somewhere, something incredible is waiting to be known, wrote astronomer Carl Sagan. On Mercury, that something lies in the missing south. As Bepi Colombo draws nearer, I imagine the spacecraft drifting through the silent heat, its panels shimmering like wings of silver, its sensors like quiet eyes studying a world older than our myths. I imagine the southern hemisphere slowly rising beneath it, ancient craters carved by forgotten impacts, frozen lava plains the color of burnt gold, and tectonic scars twisting like the lines of a sleeping face. That moment will be more than science. It will be reconciliation. And from that fuller picture, new questions will bloom. New riddles will appear. For Mercury is not a simple world, but a restless one. A world that hides hollows unknown anywhere else. A world with a magnetic field shifted off-center. A world that trails a ghostly sodium tail millions of kilometers long, like a comet that forgot it was a planet. These are the Mercury mysteries we carry into the next chapter. And perhaps that is where the deepest lesson lies, in accepting that knowledge is always unfinished, that each mission is a stepping stone across a river whose far shore remains unseen. Messenger was the first stone. Bepi Colombo will be the next. And beyond that, who can say? In the end, what touches me most is not the data, but the devotion. The quiet bravery of engineers and scientists who spent decades guiding a tiny metal traveler across billions of kilometers. They believed that Mercury had more to show us. And they were right. They believed that a small world scorched by the sun could still hold beauty, mystery, and meaning. As we wait for Bepi Colombo to arrive, I find myself imagining Mercury not as a distant object, but as a storyteller warming its voice, preparing to reveal the half of itself that has remained hidden for ages. And when that happens, we will listen. Slowly, gently, with the calm curiosity that the universe always deserves. For in the quiet between orbits, in the long pauses between transmissions, in the soft hum of spacecraft drifting through solar light, we are reminded that knowledge is not rushed. It unfolds like dawn. And perhaps, when the southern hemisphere finally comes into view, we will understand that the universe never reveals everything at once. It teaches us to be patient, to be humble, to keep looking. Because Mercury, in all its fierce beauty, is still whispering to us. And we, patient travelers of the night sky, are still learning how to listen. In the quiet cradle of the inner solar system, where sunlight strikes like molten, arrows and shadows fall as cold as ancient stone, Mercury drifts alone, a small trembling ember beside a star that never sleeps. Among its many mysteries, one stands out with a whisper both delicate and defiant. Mercury possesses a magnetic field, faint, uneven, almost fragile, yet undeniably alive. Scientists once believed such a small world could not possibly hold onto a molten heart. Yet here it is, a planet that should have fallen silent long ago, still humming with a thin electromagnetic breath. As Carl Sagan once wrote, "Somewhere something incredible is waiting to be known." And Mercury seems to embody that promise. Small, blistered, but astonishingly resilient. Mercury's magnetic field is tiny, barely 1.1% the strength of Earth's. And yet it exists, stubborn as a spark, refusing to go dark. The question is, why? Why does a world so diminutive, so scorched, so battered by the sun's relentless breath, still generate a magnetic shield of any kind? The answer lies hidden beneath its cracked crust, inside a core that refuses to freeze. A core of liquid iron swirled into motion by tides of cosmic gravity, by the asymmetry of its orbit, and by the slow ancient heat that lingers from its formation. The dynamo theory, long the lighthouse guiding our understanding of planetary magnetism, states that a magnetic field requires three simple conditions: conducting fluid, rotation, and convection. On Earth, these motions are vigorous, swirling like a churning ocean of molten metal. On Mercury, the flow is gentler, slower, but still sufficient to trace faint lines of magnetism around the planet. As the great geophysicist Dan Sheckman once noted, even the smallest structures can hold the greatest secrets. And Mercury's magnetic whisper is one such secret. But why is Mercury's magnetic field so weak, so fragile compared to Earth's? Part of the answer lies simply in size. Mercury's core is smaller. Its heat drains faster. Its convection falters sooner. Yet something prevents it from fully solidifying. Something stirs its molten metal in slow repetitions. The eccentricity of its orbit creates gravitational stretching, soft, rhythmic tides that knead the core, heating it gently, keeping its metals from falling entirely still. In this way, Mercury behaves almost like a violin string plucked by the sun's gravity, vibrating just enough to sustain a lingering note. Fragile, but real. Another puzzle makes Mercury even more intriguing. Its magnetic field is strangely lopsided, offset from the planet's center by almost 20%. It is as if Mercury's inner compass were nudged upward, leaning toward the northern hemisphere. This asymmetry is not just unusual, it is unique in the solar system. Why should a planet's magnetic heart sit off-center, askew, displaced like a lantern swaying in an unseen wind? Some scientists suggest the core might be layered, with different viscosities rising and falling unevenly. Others believe differential cooling is at play, the northern hemisphere losing heat faster, creating stronger convection. And still others whisper that Mercury may contain exotic light elements in its molten iron, sulfur, carbon, forming gradients that skew the magnetic flow. As the planetary scientist Katherine Johnson remarked when studying MESSENGER's earlier data, Mercury reminds us that even the simplest worlds refuse to be simple. And truly, Mercury is a master of contradiction. Though small, it carries a metallic core larger relative to its body than any other planet. Though ancient, parts of its surface seem geologically young. Though scorched by the sun, it keeps pockets of eternal ice in shadowed craters. Though nearly airless, it trails a sodium tail millions of kilometers long. And though it should be magnetically dead, it hums faintly, like a memory refusing to fade. As we trace each thread of this mystery, the story deepens. The weak field, the off-center dynamo, the stubbornly molten core. Each piece reveals a planet shaped by extremes. A true Mercury extreme planet. Born in violence, aged in fire, sculpted by gravity and solar wind. There is something poetic in the idea that Mercury, the smallest of the terrestrial planets, still carries an inner warmth, a glow no endless bombardment has been able to extinguish. It is as if the universe is reminding us that strength does not always roar. Sometimes it flickers, trembling, but persistent. When I reflect on Mercury's magnetic secret, I find a quiet lesson folded within it. Even the faintest field, the softest signal, the smallest core of heat, can reshape space around it. Influence is not always measured in sheer force. Sometimes it is the gentle persistence of what refuses to disappear. Mercury teaches us that resilience does not always look grand. Sometimes it looks like a tiny planet, leaning slightly off-center, yet still turning molten motion into a magnetic voice. So, as the spacecraft Bepi Colombo draws nearer, preparing to descend into Mercury's realm, we stand on the edge of new revelations, new maps, new measurements of the lopsided field that surrounds this battered world. Science progresses best when observations force us to reconsider, as astrophysicist Jeremy Bloxham once said. And Mercury is about to force plenty of reconsiderations. And in the midst of this slow cosmic drifting, with the rhythm of Mercury's molten core pulsing softly beneath its scarred crust, we are reminded that every world has a story. Every story has a heartbeat. and every heartbeat is shaped by motion. Perhaps the greatest beauty of Mercury's magnetic enigma lies not just in the answers we seek, but in the wonder it stirs. For in this small, trembling world, circling close to a star that tries to devour it, the universe whispers a truth worth carrying. Even the smallest flame can endure. And as we drift onward, I leave you with this question to ponder beneath the quiet sky. If such a tiny world can hold onto its molten heart for billions of years, what hidden fires might still be burning quietly within us? In the quiet drift of cosmic night, Mercury waits like a scarred ancient stone at the heart of the sun's furnace. Its surface is neither still nor silent, even though no winds blow and no atmosphere breathes. Instead, the planet carries a record of restless geological forces etched into its skin, a tapestry of wounds and wonders that scientists still struggle to understand. As Carl Sagan once said, the universe is not required to be in perfect harmony with human ambition. Mercury embodies that truth wholly, fiercely, beautifully. When we look at its lobate scarps, those great curling ridges that stretch for hundreds of kilometers, we see a world physically shrinking. Mercury cools from the inside out, and as its metallic heart contracts, the crust above folds like wrinkling skin on an aging celestial face. These scarps are not mere features. They are tectonic size, frozen in stone. Planetary scientist Thomas Waters once remarked, "Mercury is the only terrestrial planet where we can see the entire cooling history written across its surface." And he is right. For nowhere else in the solar system do cliffs rise from the ground as direct expressions of a world literally drawing itself inward. But then our eyes wander to Caloris Basin, a vast scar older than human imagination. A basin so immense, so violently created, that even today its outline glows across Mercury's face like the halo of some ancient cosmic wound. When the impactor struck, it unleashed energy beyond comprehension, churning the crust, lifting mountains, and plunging magma seas into temporary existence. You can almost feel time slow in the ruins of that crater, as if the planet itself still remembers the moment of its near unmaking. And the strangest part, the part that has puzzled generations of researchers, lies not at Caloris itself, but on its opposite side. There, the shockwaves converged, creating what scientists call the weird terrain. A fractured landscape that looks as though Mercury's stone surface trembled under a sound too deep for human ears. Planetary geologist Maria Zuber once said, "Mercury's weird terrain is like a geological echo that never fully died." This poetic truth lingers, for the ground there still carries the ghost of an impact that happened nearly 4 billion years ago. And if Caloris Basin reveals Mercury's violent past, then its volcanic plains whisper of an era when fire itself shaped the world. Lava once flowed like thick molten rivers, pooling in craters, smoothing ancient chaos, and painting the surface in rich hues unseen by naked eyes. Some of these plains stretch across regions larger than entire countries on Earth, suggesting eruptions that would dwarf anything our planet has ever produced. Even today, the color variations in Mercury's plains tell stories of mineral mixes and volcanic ages long forgotten. As the Messenger mission team once noted, Mercury's plains are a monument to a volcanic engine that burned fiercely before cooling into silence. Yet perhaps the most haunting features of all are the hollows. Delicate depressions that glitter with unexpected brightness. Nothing else in the solar system looks like them. Nothing behaves as they do. These hollows form when volatile materials near Mercury's surface vanish into space, leaving behind empty pockets, like breath marks on the stone. They appear young, startlingly young, as though the planet is still being quietly carved by sunlight itself. Astronomer Sean Solomon described them as features so fresh that Mercury may still be evolving beneath our gaze. And perhaps it is so. For even in its stillness, Mercury continues losing pieces of itself to the vacuum. All these clues, the scarps, the basins, the weird terrain, the volcanic scars, the ancient magma plains, the shimmering hollows paint Mercury as a world shaped by extremes. A world that records violence the way tree rings record years. A world that shows us what happens when a planet lives too close to a star. Neil deGrasse Tyson once said, "Where physics pushes hardest, the universe tells its most honest stories." Mercury is one such story, stripped to its metallic truth. From a scientific perspective, these features are invaluable. They reveal how rocky planets cool, how they store heat, how impacts reshape their crusts, and how proximity to a star alters their geological destiny. In a universe filled with diversity, Mercury stands at the extreme edge of what a terrestrial world can endure. Solar system extremes are written into every ridge, every fracture, every smooth volcanic plain. But beneath the science, there is something more personal, something quiet and human. Studying Mercury teaches us that even the smallest worlds carry deep histories, and even the harshest environments preserve unexpected beauty. The scarps remind us that everything cools with time, and everything settles into new forms. The impact basins teach us that moments of destruction can reshape an entire lifetime. The hollows whisper that nothing we think is permanent truly is. My own reflection is simple. When we gaze at Mercury's battered face, we are reminded that endurance is not the absence of suffering, but the ability to continue existing despite it. Planets, like people, carry their pasts in scars. And sometimes, those scars are what make them remarkable. So, as we continue to explore this extreme little world, drifting through the quiet dark with our instruments and our questions, we uncover not only the history of a planet, but also a quiet lesson in resilience. Mercury shows us that even in the most unforgiving corners of the solar system, beauty persists, memory persists, mystery persists. And perhaps the deepest lesson of all is this: even the smallest voice in the universe can echo across billions of years. Just as Mercury's hollowed plains echo ancient heat, and its weird terrains echo old collisions, so do we, in our own fragile way, leave traces for the future to interpret. Let this slow, drifting, meditative journey remind us of that. And as we move into the next chapter of our exploration, we carry one quiet question with us. What other secrets might Mercury still be holding beneath its ancient trembling crust, beneath the quiet breathing of the solar system? Mercury drifts like a small silver ember, locked in a rhythm so peculiar that even time seems to hesitate around it. When we speak of day and night on Mercury, we are not speaking of hours, nor even days, but of seasons of light and darkness that stretch across months. A single sunrise can linger longer than a chapter in human history, and a single sunset can feel like the slow closing of an ancient cosmic eyelid. As Carl Sagan once murmured, somewhere, something incredible is waiting to be known. And Mercury's strange dance between spinning and orbiting is one of those quiet incredibles. Mercury rotates once every 59 Earth days. A slow spin, almost reluctant, as if the planet were conserving its strength against the fierce furnace of the sun. Yet its day-night cycle lasts far longer, stretching out to 176 Earth days. This paradox, this odd stretching of time, arises from a resonance, ancient and elegant. A 3-to-2 rhythm linking Mercury's rotation to its orbit. Mercury turns 3 times for every 2 laps it makes around the Sun. A gravitational choreography locked in place over billions of years. Astronomer Scott Tremaine once described orbital resonances as the solar system's way of humming its own quiet music. On Mercury, that hum becomes a kind of cosmic lullaby. Because of this celestial resonance, an observer standing on Mercury's surface would witness a sky defying logic. The sun would rise, stall, shimmer in place for days, then slowly drift backward across the heavens like a tired lantern retracing its path. Only after another long pause would it resume its forward arc. This reversal happens because near perihelion, Mercury's orbital speed briefly outpaces its rotational speed. The planet moves so swiftly along its path that it laps its own sunrise. Einstein once wrote, "Reality is merely an illusion, albeit a persistent one." And there is no place more suitable for contemplating that illusion than on Mercury. Such distorted days give rise to a world of distorted temperatures. Sunlight pours down for months without interruption, striking the surface with a ferocity unmatched in the solar system. Without a protective blanket of atmosphere, heat cannot be held, cannot be softened. It crashes directly into rock and dust, driving noon temperatures to 430 degrees Celsius. Yet when night finally falls, it falls utterly. No air to trap warmth, no clouds to cradle the fading heat. Temperatures plunge to negative 180 degrees. From blistering fire to freezing void, Mercury breathes in extremes. Its days are furnaces, its nights are tombs. As planetary scientist Sean Solomon once said, Mercury is a world where contradictions are carved into stone. And yet, in this realm of heat and frost, ice endures. At the northern pole, deep within craters where sunlight has never touched, lie pockets of ancient frozen water, untouched for eons. The sun's rays cannot reach these hidden hollows, and in the eternal shadow, cold settles like a protective cloak. It is one of the great paradoxes of Mercury, a world that burns and yet shelters, clarity frozen in bright silence. These craters are like cosmic urns, holding remnants from the earliest epochs of the solar system. As we drift deeper into this landscape, the volcanic scars of Mercury begin to whisper their own stories. Long ago, magma surged across plains, forming fields and basins that still glow with the faint memory of fire. These Mercury volcanoes are not active now, but they are etched into the terrain like old wounds. Even in its silence, Mercury remembers its molten youth. Scientists often debate why Mercury evolved so differently from the other terrestrial planets. Some argue that its peculiar orbit, its resonance, its exposure to the sun's unfiltered breath, are the remnants of ancient catastrophes. Others believe that Mercury teaches us something deeper, something about survival. The planet does not merely endure extremes, it embodies them. It balances between fire and ice, motion and stillness, forward and backward suns. In contemplating Mercury, I find myself returning to a quiet lesson: that sometimes the harshest environments reveal the purest truths. That endurance can take the form of stillness, and that beauty can hide in contradiction. We often imagine stability as something constant. Yet Mercury shows us stability can also be a rhythm, a resonance, even a stuttering sunrise that refuses to be rushed. As I reflect on this small world, I think of how each of us carries our own extremes, our long days and long nights, our fires and our shadows. And perhaps, like Mercury, we are all searching for a resonance that keeps us steady even when the sky shifts unexpectedly. So as we drift onward through this cosmic meditation, let us hold one question gently in our hands. A question as quiet as Mercury's distant horizon. Why does a world so extreme continue to shine with such delicate, silent beauty? And what might that teach us about our own place beneath the stars? In the quiet borderland between light and shadow, Mercury breathes in a way no other world in our solar system does. Its atmosphere is not an atmosphere at all, but a fragile veil of wandering atoms, an exosphere so thin that its particles rarely meet one another. Carl Sagan once wrote that the universe is not required to be in perfect harmony with human ambition, and Mercury is proof. The closer we look, the more we discover a world shaped not by comfort but by continual escape. Mercury has no true atmosphere because it cannot hold one. Its gravity is modest, its surface brutally hot by day, freezing by night, and the unceasing solar wind tears at it with a force unmatched anywhere else near the sun. Any gas that might try to gather around this small world is swiftly lost to space, leaving behind only a drifting cloud of particles. This is how an exosphere forms, not from gathering, but from letting go. And strangely, that act of shedding makes Mercury more alive in its physics than many worlds with thick skies. These atoms come from the surface itself, loosened by the constant hammering of sunlight and by the ceaseless rain of micrometeorites, each impact small but relentless across billions of years. Solar photons knock atoms free in a process known as sputtering, a cosmic erosion driven by light rather than water or wind. The lighter elements rise first: sodium, potassium, magnesium, calcium, each ripped away in tiny shimmering bursts, invisible to the eye, but unmistakable to our instruments. Katie Mack once remarked, "The universe is not only stranger than we imagine, it is stranger than we can imagine." And Mercury's wandering atoms embody this truth. A world with almost no air somehow becomes one of the most dynamic laboratories for studying planetary loss. From this gentle escape emerges Mercury's most haunting feature: a sodium tail stretching nearly 2.5 million kilometers into space. This tail is not smoke, not dust, not even anything visible to our ordinary senses. Instead, sunlight acts like a silent shepherd, pushing sodium atoms away from the planet with each absorbed photon. Even though a photon has no mass, it carries momentum, and when sodium absorbs this energy, it receives a tiny but persistent push. Push upon push, nudge upon nudge, millions of times per second, over distance that becomes a river of escaping atoms. In this way, Mercury mimics a comet, not because it is icy, but because it is constantly shedding itself, losing atoms into the infinite night. Giovanni Cassini once wrote, "Nature is inexhaustibly subtle," and Mercury's tail is an example of that subtlety. A world baked by heat, stripped by radiation, becomes a celestial lantern, drawing a glowing trail behind it as it orbits. Yet we cannot see this tail with the naked eye. Its light is faint, overwhelmed by the brilliance of the sun, and its color belongs to a very specific wavelength. Sodium glows at 589 nanometers, the same golden hue as old street lamps. Only by filtering out everything except that narrow band does the tail appear, like a ghost emerging from darkness once the right spell is spoken. Many astronomers describe the moment of detection as otherworldly, an entire structure revealed only when the universe whispers its light at a frequency of its own choosing. As our telescopes observe Mercury's tail change with its orbit, we learn how a world interacts with its star, how radiation shapes planetary surfaces, how a fragile exosphere can tell the story of a planet's past and future. The sodium tail brightens and fades with Mercury's distance from the Sun, swelling after perihelion, dimming as the planet slows again. Through this movement, we glimpse a dialogue millions of years old, a conversation between heat, gravity, light, and stone. Personally, I find something deeply moving in this phenomenon. Mercury is harsh, airless, battered. Yet through the violence of its environment, it becomes radiant, trailing a ribbon of golden atoms across millions of kilometers. It loses something of itself, and in losing, reveals beauty. There's a lesson there, one that reaches beyond science. Sometimes what we think of as erosion, as loss, is also expression. Sometimes the most fragile things, like sodium atoms drifting in the dark, carry the clearest messages about resilience. Neil deGrasse Tyson once said, "The universe is under no obligation to make sense to you." But Mercury, in its quiet way, tries. Its exosphere shows us how worlds breathe without air. Its sodium tail shows us how sunlight writes delicate signatures across space. And its surface, continually stripped and renewed, teaches us that change is as natural to planets as it is to people. As we study this world, we learn not only about Mercury, but about our own beginnings, our own fragility under the same sun. Perhaps that is the real value here. In the faint glow of the Mercury sodium tail, we see the poetry of physics, the patience of geological time, and the quiet truth that even the smallest worlds leave grand traces in the dark. And in that golden whisper stretching millions of kilometers, we are reminded of our place, small, luminous, and endlessly shaped by the star that made us. Mercury, sodium tail, Bepi Colombo, drifts through the dark like a threefold lantern carried across the cosmic sea. Its body is not one vessel but a union of travelers, three spirits bound together for a single purpose. The Mercury transfer module holds them gently like a mother cupping two delicate hearts. Beside it rests the Mercury planetary orbiter from ESA, a watchful eye meant to study the scorched surface and the iron depths below. And on the opposite side floats Mio, the magnetosphere orbiter from JAXA, a quiet listener built to hear the whispers of fields and charged particles around the innermost world. Together they resemble an ancient caravan moving across a desert of stars. None of them could finish the journey alone. For Mercury is a world that demands humility, adaptability, and most of all, patience. Scientists learned long ago that approaching Mercury is like approaching a skittish wild creature, one that flees toward the sun's gravity well the moment you get too close. So Bepi Colombo must travel as a trinity, each part making up for what the others lack. The transfer module is the powerful breath behind them, pushing the formation across 8.5 billion kilometers of sunlit emptiness. It carries the electric propulsion, the solar arrays, the stability needed for 7 years of flight. Without it, the orbiters would be two fragile leaves caught in a solar hurricane. But the orbiters, in return, carry the purpose, the sensitivity, and the eyes to see what Messenger once began to reveal and could never finish. The Messenger spacecraft findings taught us two unforgettable truths. First, Mercury is far stranger than we ever imagined. And second, one spacecraft alone can never tell the full story. Messenger mapped only one hemisphere in detail, and its instruments sensed only a portion of the magnetic symphony playing around the planet. As the late astronomer Carl Sagan once said, "We are a way for the cosmos to know itself." And so to know Mercury, we must return with more eyes, more angles, more willingness to listen. That is why the orbiters must ride in silence during the journey. Many of their instruments cannot be activated now, not because they are fragile, but because the geometry of flight makes their data meaningless before arrival. Sensitive detectors would be blinded by heat, star trackers confused by the stacked configuration, electromagnetic sensors muffled by the presence of the transfer module. Their moment of awakening must wait until the separation, when each orbiter spreads its wings into Mercury's orbit like petals unfurling at dawn. When that moment comes, ESA's orbiter will circle low, brushing closely above crater rims, lava plains, and the mysterious hollows that shine like scars touched by starlight. JAXA's MEO will soar higher, looping through the magnetosphere, tasting the fluxes and turbulence where Mercury's tiny dynamo pushes back against the Sun's endless storm. As astrophysicist James O'Donoghue once remarked, "If you want to understand a world, you must understand its relationship to the star that shapes it." And Mercury, more than any other world, is shaped by the Sun's breath. Its exosphere is not an atmosphere but a ghost, a fleeting haze of sodium, potassium, calcium, magnesium, stripped from the surface grain by grain. Some atoms are knocked free by solar wind, some by micrometeoroids, some by light itself. This thin veil rises and falls with the rhythm of Mercury's orbit, creating a tail millions of kilometers long, trailing through the dark like the shimmering train of a comet's gown. To study such a fragile structure, you must view it from different angles. One orbiter must look outward, toward the tail, measuring the atoms that escape to space. The other must look downward, at the surface where those atoms are born. As physicist Freeman Dyson said, "New directions in science are launched by new tools much more often than by new concepts." And here, the tools are the distinct vantage points of two orbiters traveling in harmony. The magnetosphere of Mercury is even more elusive. It is small, compressed, breathing like a tired lung under the Sun's pressure. MESSENGER found reconnection events 100 times more frequent than Earth's. Bursts of electrons that flash like lightning within a magnetic storm. But it only tasted the northern hemisphere, never the full system. To truly understand it, MEO must ride through the outer boundaries while ESA's orbiter threads through the inner layers. Only with both can we draw the first complete map of a magnetosphere sculpted on the doorstep of a star. The more we learn, the more Mercury becomes a mirror reflecting our own curiosity back at us. A world burned, battered, eroded by forces older than memory. Yet it endures, dignified in its scars, quietly carrying the story of the early solar system like a stone carrying the warmth of an ancient fire. I often find myself imagining the moment Bepi Colombo finally separates. The modules drifting apart. Not like machines, but like companions who have walked a long road together and now choose different paths. There is something deeply human in that image. Something about letting go, about trusting each piece to fulfill its purpose in the silence that follows. My own belief, shaped by years of watching these missions unfold, is that the true lesson of Mercury is perspective. To understand a world so extreme, you must be willing to look from many angles, to combine patience with humility, to accept that no single viewpoint holds the whole truth. The planet teaches us that knowledge is rarely found in the loudest signals, but often in the faint, trembling, easily overlooked ones. In that sense, Bepi Colombo is more than a mission. It is a reminder that discovery is a collective act, a layered melody rather than a single note. It tells us that even in a universe filled with fire, gravity, and relentless light, the most fragile things are sometimes the most revealing. And as we drift with the spacecraft through this long twilight journey, we are invited to slow down, to breathe, to feel the vastness around us. science becomes a kind of meditation. The cosmos, a quiet teacher. One day, when Bepi Colombo arrives, its instruments awakening like petals touched by sunrise, we may finally glimpse the truths, Messenger began to whisper. We may understand why Mercury's exosphere glows, why its magnetic field trembles, why its surface holds memories of oceans of fire. Until that day comes, we drift with it, crossing billions of kilometers in silence, listening to the universe breathe. The closer we drift toward Mercury, the more its silence begins to sound like memory. A quiet world etched with ancient scars, where every crater is a frozen echo of something violent and long forgotten. Among these scars, certain names rise like constellations carved into stone. Calvino, Lermontov, Haydn. They are not merely holes struck by celestial debris, but windows into a deeper story about the planet's skin and the forces that once shaped it. As Carl Sagan once said, every world has a biography, written in dust and fire. And nowhere is that more evident than in these craters that whisper Mercury's earliest chapters. Calvino's smooth interior and bright rim hint at minerals tugged from below the surface, materials that were once hidden deep in the crust until the impact peeled the layers open like a cosmic fruit. Lermontov glows faintly in the ultraviolet, suggesting the presence of unusual compounds that Messenger spacecraft findings first noticed but could not fully explain. Haydn holds streaks of volcanic residue, not from a recent era but from a Mercury that once throbbed with molten breath. These landscapes become more than relics. They become testimonies, clues, promises that the crust of Mercury is far more intricate than a dead rock scorched by the sun. Yet as we glide slowly above these basins, another mystery begins to rise. Something soft, something strange. When Bepi Colombo and Messenger drifted past Mercury, the instruments trembled, ever so slightly, capturing vibrations that were later transformed into sound. A haunting sonification of data that allowed us to quite literally hear a world that has no air. The universe is under no obligation to make sense to you, Neil deGrasse Tyson once said. And yet there is a strange comfort in hearing Mercury sing through numbers and frequencies. Sonification is a simple idea wrapped in quiet poetry. Each shift in magnetic intensity, each tiny acceleration of the spacecraft, each ripple in the magnetosphere, all of it is converted into tonal changes we can hear. These tones do not reflect sound as it exists in air, but sound as it exists in meaning, in pattern, in structure. It is like listening to the heartbeat of a stone, steady, ancient. When the pitch drops, the magnetic field intensifies. When the pitch flutters, turbulence ripples along Mercury's magnetosheath. And for a moment, we feel less like observers and more like travelers cupping an ear to a world that should have remained silent. What surprised scientists most was the way these vibrations intensified when the spacecraft slipped into Mercury's shadow. A brief eclipse where sunlight vanished. Radiation pressure collapsed, and the craft moved through a pocket of changing forces. Spacecraft do not simply glide through darkness. They feel it. They respond to the shifting balance of heat, light, and magnetic pressure. Crossing into shadow cools surfaces rapidly, triggering subtle contractions in the structure, leaving the instruments to register the slightest shiver, like a ship's hull creaking as it enters colder waters. Emerging back into sunlight does the opposite. The spacecraft warms, expands, and the accelerometers record another wave of micro-tremors. It is an elegant reminder that even machines are not immune to the emotional weather of space, though their emotions are measured in microns and millijoules. Standing back from all this, I find myself drawn to the idea that Mercury is teaching us something subtle but profound. We often speak of planets as objects, frozen, inert. Yet Mercury seems to resist stillness. Every crater exposes hidden minerals. Every bright patch hints at a vanished substance. Every low-frequency tone reveals the quiet tension between sunlight and darkness. It is as though the planet is still rewriting itself, slowly, patiently, even though its surface has not known a new volcano in billions of years. Calvino shows us how impacts sculpt and rearrange Mercury's crust, redefining what lies above and what lies below. Lermontov shows us how minerals react to sunlight in ways we still do not understand. Haydn reveals the fingerprints of a volcanic era so ancient that the heat is now only a memory. Each crater becomes a classroom, each shadow a chapter, each bright ray a footnote written by falling stars. And here, weaving through all these lessons, is the gentle music of sonification, a method that transforms raw data into something the human heart can feel. Hearing Mercury's magnetosphere tremble as the spacecraft crossed the boundary between sunlight and shadow reminded me of an idea spoken by the physicist Freeman Dyson. The universe shows us as much as we are ready to see. Perhaps Mercury has always been vibrating like this, but only now are we sensitive enough to listen. From the Messenger spacecraft findings to the ongoing journey of Bepi Colombo, each mission is peeling back the outermost layers of Mercury's biography. A biography written not in words but in impact melt, mineral spectra, magnetospheric tones. These layers remind us that the smallest world in the solar system can still hold enormous secrets. In the quiet of reflection, I find a personal lesson rising from Mercury's barren plains. A lesson about endurance. The planet is tiny, battered, heated by relentless sunlight, and stripped of its surface materials by the solar wind. Yet it remains, steadfast, orbiting, shining. In a universe where even stars collapse under their own weight, Mercury survives by simply continuing. There is a kind of wisdom in that, a reminder that survival is not always about strength, but about patience and the willingness to endure cycles of light and shadow. The spacecraft that visited Mercury felt these cycles, trembled under them, adapted. And we can too. As the camera drifts away from Calvino's rim, rising above the faint blue sodium glow that trails behind the planet, one thought lingers. Mercury is mysterious not because it hides itself, but because it reveals only what we take the time to understand. In its quiet trembling, in its ancient craters, in its music of magnetic fields, the planet is offering us a final question, soft as stardust. What other worlds in our solar system are singing to us, waiting for us to finally learn how to listen? Is less than The story of Mercury unfolds like a trembling thread of light at the edge of the Sun, a place where the fabric of magnetism bends and shivers in ways unseen elsewhere in our solar system. When scientists speak of magnetosheath turbulence around this scorched world, they describe a realm where charged particles whip and churn like restless spirits pressed against a fragile magnetic shield. The solar wind arrives with the ferocity of a star-born storm, rushing at millions of kilometers each hour, striking Mercury's tiny magnetosphere so close to the surface that it rattles like a drum stretched too thin. This region becomes a sea of fluctuations, a chaotic ocean of field lines snapping and reconnecting in rapid bursts, each one a silent explosion of energy. One researcher once whispered that studying Mercury's magnetic turbulence is like watching a candle flame in a storm that never ends. And that image has always stayed with me. As Dr. Jim Slavin of NASA remarked, Mercury gives us magnetic storms on fast forward. Everything that takes hours at Earth happens in minutes there. The magnetosheath becomes more than physics. It becomes a metaphor for the fragility of worlds, a place where the pressure of a star shapes the destiny of a planet too small to grow a stronger shield. Listening to the data sonified into trembling tones, one can almost imagine the planet breathing, shuddering, enduring. And as I follow these ripples in field strength, I am reminded that even in extreme environments, there is a kind of cosmic resilience that speaks to the quiet endurance of the universe itself. As the narrative slides deeper into Mercury's luminous strangeness, we encounter one of its most delicate mysteries: the sodium tail that sweeps behind it in a pale golden arc. The fact that this tail shines brightest 16 days after perihelion is no coincidence. It is a dance choreographed by velocity, sunlight, and the shifting wavelengths our instruments are built to see. When Mercury swings closest to the Sun, it does not yet reveal the full brilliance of its sodium plume. That spectacle waits until the world begins to flee outward again. As Mercury accelerates away from the Sun, its motion stretches the wavelength of sunlight through Doppler shift, sliding solar lines into positions where sodium atoms can absorb them more efficiently. What had been dim becomes radiant. What had been swallowed by the solar spectrum becomes unveiled. As the great astronomer Joseph Wampler once wrote, "In the shifting of wavelengths we do not merely measure motion. We witness the universe adjusting its voice." It is this adjustment, this cosmic tuning, that causes the sodium tail to glow brightest in the days after perihelion. Each atom becomes a tiny lantern, pushed outward by radiation pressure, drifting into a 1,000,000-kilometer ribbon of light that our telescopes can only glimpse on rare nights. Even now, every time I imagine that golden tail, invisible to the human eye yet immense beyond comprehension, I feel the quiet wonder that only the universe can summon. But the grace of this sodium tail is matched only by its elusiveness. Observing it from Earth is a delicate art, a threading of celestial needles that almost never line up. Mercury must be far enough from the Sun's glare to stand independently in the twilight sky, yet not hidden behind the Sun from our perspective, and not angled in such a way that its anti-solar direction slips beyond our view. These constraints act like cosmic riddles, asking us to wait, to time our instruments, to anticipate alignments that may not come for years. As Dr. Louise Proctor has said, Mercury reveals itself only when the heavens feel generous. And so astronomers watch, patient and persistent, knowing that the tail may appear only for moments, faint and trembling, like the ghost of a comet that never was. The rarity of these observations does not diminish their meaning. Rather, it sharpens it, reminding us that not all truths are meant to be seen often. Some are meant to be cherished precisely because they are fleeting. When I reflect on these phenomena, from the turbulent magnetosheath to the shimmering sodium tail, I find myself thinking of Mercury less as a planet and more as a kind of cosmic lesson. It teaches us that small worlds can host great mysteries, that the universe does not reserve grandeur only for the giants. It reveals that even the most extreme environments can produce beauty, and that even the faintest light can travel millions of kilometers to touch our telescopes. In the turbulence around Mercury, I see the reminder that pressure shapes us, sometimes violently, sometimes creatively. In the Doppler-brightened sodium tail, I see how motion changes perception, how distance modifies truth. And in the rare alignment that allows us to see that tail at all, I see the quiet wisdom that some discoveries require patience, humility, and the willingness to look up even when we expect nothing. Perhaps that is the lesson Mercury leaves us, whispered in golden ions and trembling magnetic waves, that the universe rewards those who continue to watch, continue to wonder, continue to seek the faintest signals in the cosmic dark. For as Carl Sagan once said, somewhere something incredible is waiting to be known. And on nights when Mercury's tail brightens against the void, I feel certain he was right. In the quiet cradle of the early solar system, when dust and flame drifted together like ancient dancers, a small world began to gather itself from chaos. Mercury was born not in comfort but in the furnace, shaped by collisions so violent that even today its body still remembers the blows. Scientists believe that in those first ages, a giant impact may have torn away much of its outer shell, leaving behind a world with a heart almost entirely exposed. As the planetary scientist Sean Solomon once said, Mercury is the survivor of a catastrophic past, a relic stripped to its core. Its metallic core, astonishingly large at nearly 70% of its mass, tells that ancient story with a calm and steady glow. No other terrestrial planet carries such a heavy heart, and yet this density brings Mercury close to Earth in weight per volume, even though Mercury is far smaller. It is a world compacted into itself, forged by cosmic violence, polished by time. Neil deGrasse Tyson once remarked, "Mercury is what you get when the universe hammers a planet down to its final essence." But this strange child of the sun has no companion, no moon to circle it, no gentle partner to share the long burning days. The sun's pull is too powerful. Its gravity, a tidal command that allows nothing to linger, nothing to drift within Mercury's reach. Any small body would be stolen away, swept into the sun's embrace or cast back into interplanetary darkness. In this fierce gravitational well, Mercury travels alone. The orbit it follows is an ellipse stretched taut, the most eccentric path in our planetary family. At perihelion, Mercury rushes inward as though falling, drawn by the irresistible call of the sun. At aphelion, it drifts farther away, breathing a momentary sigh of cosmic relief. Einstein once described Mercury's motion as the handwriting of space-time itself, and indeed, its shifting orbit became one of the earliest proofs of general relativity. The planet's path is not simply a line in space, but a whisper of physics at work. Yet even without an atmosphere, even without air to stir across its plains, Mercury's surface continues to evolve. Slumping occurs where ancient crater walls can no longer bear their own weight, slowly collapsing inward like tired giants settling into sleep. Scarps, long cliff-like ridges, reveal the steady cooling and shrinking of the world beneath. The planet is tightening over time, its crust folding into itself. In the long nights, when temperatures plunge to bone-breaking cold, thermal erosion gnaws at rock layers, cracking surfaces that have faced billions of sunrises and sunsets. It is silent change, patient change, but change nevertheless. When I look at Mercury, I see not a barren world, but a memoir written in scars and shadows. Every ridge, every fractured basin, every smooth plain filled with ancient lava, speaks of forces immense and unforgiving. And yet, the planet endures. Perhaps that is the quiet lesson Mercury offers us, that even the smallest among us can survive the greatest storms, that even a world stripped to its heart can continue on its orbit with dignity. In its loneliness, it teaches resilience. In its silence, it teaches patience. In its fierce proximity to the sun, it teaches courage. When Carl Sagan once said, "The cosmos is within us. We are a way for the universe to know itself," I think Mercury understood that truth long before we ever whispered it. For by studying this small, burning world, we learn something about how creation reshapes itself, how chaos becomes structure, and how even destruction can give form to wonder. As I reflect on Mercury's story, I am reminded that our own lives bear similar marks, shaped by pressures unseen, by forces vast and intimate. And just like Mercury, we too carry a core that remains unbroken. So when you picture this extreme planet, drifting in its long elliptical solitude, scorched by day and frozen by night, let yourself breathe with it. Let the rhythm of its orbit echo softly in your thoughts. For in the quiet of that reflection, Mercury becomes more than a world. It becomes a reminder that even in the harshest light, something beautiful can survive. In the quiet twilight between starlight and memory, Mercury reveals one of its strangest wounds. A pattern of fractured ridges spreading outward like shattered glass. Pantheon Fossae and its offset heart. Apollodorus. A formation so peculiar that even seasoned planetary geologists pause before it, whispering the same question. What broke this ancient world from within? Some scientists have long suspected that the fracture pattern is the signature of upward violence. Not something falling from the sky, but something rising, slow and relentless. Perhaps a surge of magma had once pushed against the crust, swelling, straining, until the surface burst into radial cracks like a frozen lake struck from beneath. The absence of a central crater strengthens this quiet suspicion. As Dr. Louise Proctor once remarked, Mercury often tells its stories sideways, not with the scars we expect, but with the scars it invents. Yet others believe the planet's tortured form hints at a deeper heartbeat, the restless churn of a core that should have died long ago. Mercury is small, cold on the outside, ancient beyond measure. By all logic, its molten center should have solidified eons ago. And yet, it still pulses, generating a magnetic field that scientists describe as exhausted but alive. How does such a tiny world keep its inner fire? The answer may lie in its eccentric orbit, an ellipse stretched thin like a bowstring. As Mercury swings closer and farther from the Sun, tidal forces knead the planet's interior, flexing it again and again. Each cycle generates friction, heat, and the slow stirring needed to power a dynamo. Dr. Sean Solomon, who led NASA's Messenger mission, once explained, "A world so small should be silent, and yet Mercury hums with the remnant heat of its ancient struggles. Without a moon to tug upon it, Mercury relies solely on the Sun's harsh embrace, a gravitational rhythm that shapes both its orbit and its soul. But the mysteries do not stop at its core. They rise into the thin, ghostly veil that Mercury calls an exosphere, a place so sparse that atoms drift like lost thoughts, rarely touching. Within this fragile envelope, magnesium and calcium behave like two characters from different myths. Magnesium tends to stream outward on the night side, carried by light, pressure, and particle interactions, while calcium blooms at dawn, appearing in sudden bright surges as though awakened by the first touch of sunlight. This asymmetry puzzled scientists for decades, until observations revealed that each element responds to solar radiation differently, absorbing, scattering, and escaping according to its own delicate physics. The exosphere becomes a kind of cosmic choreography, a slow dance between atoms and sunlight. Yet the most haunting phenomenon may be the bursts of high-energy electrons that Messenger detected near Mercury's northern hemisphere. These electrons appear in rapid, almost violent pulses, as though some unseen force is cracking open magnetic field lines and flinging charged particles through space. Why the north? Why not the south? One hypothesis points again to the offset magnetic field, shifted upward by nearly a fifth of the planet's radius. This imbalance funnels solar particles into the north more easily, creating storms of electrons that surge through magnetic channels like lightning trapped inside an invisible cage. As Dr. James Slavin put it, Mercury's magnetosphere is the most dynamic and temperamental we've ever studied. A storm system made of pure magnetism, seen together. These mysteries do not feel separate. They feel like chapters of one long story. A story of a world carved by heat, bent by gravity, and sculpted by an unforgiving sun. Pantheon Fossae becomes more than a fracture field. It becomes a memory, a frozen echo of a time when the planet's crust strained against forces rising from below. The warm core becomes more than a curiosity. It becomes the embers of a fire that refuses to die. The strange behavior of magnesium, calcium, And electrons becomes more than data. It becomes proof that even the smallest world has its own rhythms. When I reflect on Mercury, I see a lesson written across its battered surface. Even the smallest among us carry immense histories. Even those who appear silent may be burning on the inside. Even the most fractured places can be the ones that reveal who we truly are. Perhaps that is why Mercury feels so human. It is cracked, uneven, pulled in different directions by forces it cannot control. And yet, it endures, still holding on to its faint magnetic heartbeat. If there is a message hidden in those shattered ridges, it may be this: that resilience is not the absence of breaking, but the quiet persistence of continuing to shine in the aftermath. And as we drift gently toward the next question, one wonder remains suspended in the dark. What other secrets might a world like Mercury still be waiting to reveal?